In the following integrals, circle the u and find the du. After that, find the integral. So remember, a good choice for u is things under a square root, things in a denominator, things that are exponents, things raised to powers. So in this case, I'm going to pick my u to be tangent of x because that's what's underneath the square root. So I have u equals tangent of x. Remember, to find du, you just take the derivative of tangent. Okay, so the derivative of tangent of x we know is secant squared x dx. So what you should notice is that here, right at the end, you have that du. So when you rewrite the integral, you get the square root of u times du. It's easier if you rewrite it as a power, so u to the 1/2 du. To integrate that, add 1 to the power, divide by the new power, plus c. So 2/3 u to the 3/2 plus c. Again, when you start with x's, you want to end with x's, so replace that u with tangent of x. And you have 2/3 tangent of x to the 3/2 plus c. Okay, so 20x cubed times the 5th root of x squared plus 1. So again, if you can, pick stuff inside of roots. So I'm going to pick my u to be x squared plus 1. The derivative of that is 2x dx. Okay, so this one's going to take a little bit more creativity because when you look at what's here, we have x cubed and our du only needs x squared. So I'm going to do this one a little bit differently, and I'm going to say du divided by 2x is dx. And now I'm going to rewrite. So I have 20x cubed square root of u times du over 2x. When I simplify that, these 20 and 2 cancels, I leave with 10. One of these x's canceled, so I'm left with x squared square root of u. I want this all to be in the same variable though. And so what I'm going to do is I'm going to solve this for x squared. And to do that, I'm going to subtract 1 from both sides. So x squared is u minus 1. So here, instead of writing x squared, I'm going to write u minus 1. So I have 10 u minus 1 square root of u du. Okay, if I do a little bit more simplifying, I have 10u minus 10. Square root of u is u to the 1/2. And now I'm going to distribute that. So I have 10u to the 3/2 minus 10u to the 1/2 du. Okay, so when you integrate, you add 1 to the power. So 3/2 plus 1 makes 5/2. Divide by the new power. Same thing with this one. 1/2 plus 1 makes 3/2. Divide by the new power, plus c. Okay, so 10 divided by 5/2 is 4u to the 5/2 minus 10 divided by 3/2 is 20 over 3 u to the 3/2 plus c. Again, I started with x's, so I want to end with x's. So if I go back up, I notice that u, remember, is x squared plus 1. So down here in my integral, everywhere I see a u, I'm going to write x squared plus 1 to the 5/2. And then again, replace that u with x squared plus 1 plus c. So sometimes not everything in your integral will cancel out when you find your u and du, and you have to be a little bit creative and see, can I do some replacing to get rid of the rest of the stuff? If not, you might have picked badly and you'll have to go back and pick a different u. That's okay too.